Hi everyone, Dave Zidel here. I'm just going to take you through a summary of the stuff that you've done in Unit 1. In case you need a little bit of clarity, this will be a summary of what you could have been through or what you should have been through on the videos, and hopefully will clarify some of the things that maybe you were unfamiliar with. The topics we're going to cover, we'll just talk about relational databases, different types of data, contrast rational unstructured data, and then we'll talk about some of the common data manipulation functions, some of the financial concept, or not financial, but statistical concepts, and then we'll unpack the quiz. I'm going to run through this very quickly. You've got your main videos to go back and watch, but just to highlight some things that might be important. So first of all, relational databases. When you look at relational databases, this is a relational database. It's just looking at things that are in the rows and things that are in the column, and they relate to each other. So that's what a relational database is. What's important to know is that the things in the row are called the observations, and the things along the top or the columns, those would be called the variables. So you have a number of observations within the variables. So we're going to look at the 4 types of data. Important for you to understand this. We've got categorical data, also known as qualitative data. We've got ordinal data, continuous data, which is split into 2 types, interval and ratio. And then there's also unstructured data. Your categorical data is also known as qualitative data. Important with this that you might have missed from your lectures maybe is the level of statistical information. So this is a scale, and on the very low end is the categorical or qualitative data. The quantitative data is more on the higher end. So it's important to see where on this it fits within the scale, because there's less that you can do with this statistically on the ones that are on the lower end. So your very lower end is your categorical, or what's known as qualitative data. That would give you things like just your location. And then you've got ordinal data. Ordinal data is similar to what you had before, but it's categorized in rank. So previously, if I've got an urban mall, suburban store, there's no real rank between them. These have ranks. So you categorize them, and there's a particular order that they can fall into, and that makes it ordinal. Higher up on the statistical, so now we're looking at the level of statistical information, is your interval and your ratio. And what this is giving you the data that you can now start analyzing, but interval does not have a natural zero, a ratio does have a natural zero. So in other words, interval shows you that there's an interval between different things, but there's no zero. When we say zero, if we ask you how much money have you got in the bank, there's an interval and there can be a zero. This over here is unstructured data, so you can read up on that. Relational database, the relational databases store categorical, ordinal, and continuous data. Unstructured data, we use different ways of trying to understand it, so we can understand it, text analytics, machine learning, etc. We're not going to be doing this as part of this course, but just so that you know that that's how it would be analyzed. So words, writing can be analyzed using machine learning, etc. Let's just go back quickly over this. So your descriptions over here, if I can move myself out the way. Your data types, your categorical, remember we said it's called qualitative or nominal. So you got categorical, ordinal, interval, and ratio. Your categorical is categorized as discrete names or data, like the name of a book, the type of school that you went to. Ordinal refers to the quantities that have a natural order. For example, if you have runners coming across the line, there's an order. First one came first, second, third, fourth. The difference or the gap between the person who came first and second might not necessarily be the same gap as the person who came second and third, and therefore it's ordinal, but it's not interval. Your interval data is very similar to that, but now the gaps between each one is the same. And then your ratio data, very simple. If you want to know something ratio, has it got an absolute zero? Okay. The problem, and why it's important for you to understand this, is that you must not make interval or ratio claims about ordinal data. Okay. So people draw the wrong conclusions. So if you're doing a survey and somebody rates a product as a 4 and another product as a 2, you can't just say that this is double the satisfaction of this one. So that's kind of the problem and why we need to understand these things. Important, there's the Likert scale, type scale, which we all kind of should be familiar with, asking people their opinions. Are you satisfied? And at a scale of 5, there's some discussion around this, whether it's ordinal or continuous. General thinking is if it's discrete like this, then it's ordinal. If the same thing is asked, but with a sliding scale, then it's more continuous. But that's as much as you need to know in that regard. If I had to ask you which of the following statements is incorrect. Now, what we've got here is nominal and ordinal data is qualitative. It's on the lower end of the statistical scale. Your interval and ratio is quantitative. So ordinal data may be described as qualitative. Ordinal data, qualitative, yes, that's correct. Nominal data may be described as qualitative. There's nominal, it's qualitative, yes. Let's go to, a categorical variable may produce ratio data. Can categorical falls over here. Can it do ratio there? Nah. A discrete numerical variable may produce ratio scale data. Discrete ratio, yes. So the incorrect one would be this one, number C. Okay, so just important with this really is understanding qualitative is there and quantitative is there. Another quick test. Each scale is represented once. List them. So if we have a look at these things, how would you list these things? So your favorite candy bar. I can list my candy bars. I can put them in a category, yes, but is there a 0? Can I go and set intervals? So that is just nominal. I can nominate it. Weight of luggage. If I'm looking at the weight of luggage, can be 0. Very simple. That then would be ratio. Year of birth, it is in an order, and that order goes up in even steps basically, so it's interval. And your egg size would be obviously then ordinal because it goes up in an order, but the difference between small and medium is not necessarily the same as between medium and large. You're okay with that? So ask another quick one. Each scale is represented again by one of these. If we put a military rank, there is an order within the military rank. Is there a 0? No. So we can take out that. We can take out that because there is an order. Is there a set interval between the two? No, there's not. So it is ordinal. Number of children in a family, can that be 0? Yes, so that would be ratio. Shirt number for a soccer team, okay? That would be nominal. It's just a nominal number on the shirt. Shoe size, there's a gap. So you can't put, going back to this one, you can't put the soccer player that number 9 is doubly as good as number 10, for instance. Okay. I hope that kind of gives you a little bit more insight about it. Who cares about data types? Well, we do, because we're trying to analyze something. And the general rules is when you're doing a survey, if you're starting to gather some of the data, try as much as possible to get a higher level of statistical information. So go up the scale rather than down the scale because you can do more with that. Doesn't mean you can't do anything with the others, but the higher you go up, the more you can do with that. On the course, you've gone through a couple of these. Just make sure that you can look at those, the transforming the data, the flipping it over, if statement, the combining, the AND function, VLOOKUP, and recording macros. I'm not going to take you through that. If you want to go through some of these things, there's lots on the internet. Go Google some of these things, and if you're not sure how to do it, I'm sure you could teach yourself if what is given on the actual course isn't sufficient. We're going to look at a number of things of counts. We're going to talk about central points, mean, median, mode, distribution measures, and association measures. And important for you to learn how to do pivot tables. Again, Google it if you don't know how to do it. If the course doesn't give you sufficient, it's not meant to be an Excel course. So go and find something in Excel. Pivot tables. To answer the quiz, you're going to need to be comfortable with the use of pivot tables. Just very briefly speaking, if we're looking at the levels of analytical usefulness, important for you to understand that when we talk about counts, percentages, average, that's what we call descriptive analytics. And that's kind of the beginning of it, the lower end of it, the scale is the descriptive statistics, and we're going to look at a lot of that. So looking at the summary of statistics, the key point here and why we're looking at this, we're looking at two key things to understand a data set is where's the middle of the data, the central tendency, and how widely spread is it? What's the dispersion of it? So when you're analyzing it, we're looking at that central point, we're looking at dispersion, we're also looking, is it symmetric or is it skewed? So what we call the normal distribution, that bell-shaped curve, that's symmetric. The two sides are equal to each other. The others, it could be skewed. And then the kurtosis is measuring the peak of the data. Important to know that the so-called normal distribution is not normal. It's not normal to get a perfectly normal distribution. Your measures of central tendency, so when we're looking at the middle of the data, we're looking at the arithmetic mean, which is what everyone, when you talk about the average, you're talking about the arithmetic mean. We just refer to it here as the mean. You've got other things. You've got a weighted mean, and you've got moving averages, but we're going to concentrate on the mean. The median is the middlemost point. That means half the data points lie above it and half below it. The mode is the one that the data points or the number that occurs the most often. Okay. So this would be your normal distribution curve. The important thing for you to understand here is that this point in the middle would be your mean. Half the points lie above it, half the points lie below it. That is your mean. We will show you just now how to calculate a standard deviation. And if you calculate what that standard deviation is, we say if we take one standard deviation above the mean and one below the mean, you are encompassing in this group 68% of all the data points. If you had to add another standard deviation and subtract another one, so you're doing two standard deviations, within this area is 95% of all the data points. So that's an important thing to understand. We'll get to another one, which is your interquartile range, but we'll talk about that a little bit later. So if you have a look at this, about 65% of the population lies one standard deviation either side. Well, it's about 65%. Generally, it's known as 68%. But how do you calculate that standard deviation? You just take your data set and you put in the formula, standard dev, and whatever the range is, and it calculates it for you. Your interquartile range, you calculate with a percentile, and you take 0.25 and percentile of that data range, 0.75. What this gives you is the percentile tells you what is really the median of the bottom half and the median of the top half, and the difference between those is your interquartile range. Let me explain that again. So we talk about an IQR, interquartile range, the range of the middle 50% of all the data. So remember with this, we're looking at the middle 68%. If you take the mean and one standard deviation on either side, over here we're looking at the 50% of the middle data. It's the median of the top half of the data minus the median of the bottom half of the data. So the way you would work it really is this. If I've got all these data points, if I have a look here, 1, 2, 3, 5, 6, 7, 8, 9, 10. I've got 11 data points, 5 of them on this side, 5 on this side. The median would be 12. If I take the median of the bottom half, so I've got 5, so I take that middle data point, then that would be the median of that half. And if I take these 5 and I find the middle point, which is 18, and then I subtract the 18 from the 10, that gives me the interquartile range. In this case, 18 minus 8 would be 10. And that's the interquartile range. It means roughly about what we assume 50% of all the data points would lie somewhere between 8 and 18. When you're choosing a technique to use, please go back to your notes and have a look at this. This is quite a useful table, just saying depending on the data that you've got, what is the best way to analyze it. So just go back and read up on that. Your outputs would basically be done or look like this when you're doing some basic analysis, when you're relating categorical and ordinal variances. And what you're landing up with is a combination of these things in terms of this. People were safety trained, people were not safety trained. Okay? And then were there safety incidents, safety trained? No safety incidences in that 2-year period for people that were safety trained. 25% had minor incidences, and here 3% had major incidents. If they were not safety trained, there's a difference. 56% had no incidences, 36% had minor incidents, and double that amount had major incidents. And that's how you kind of read that table. And this is called ordinal data because it kind of, can you see it scales up from nothing to minor to major. It's in that particular order. Correlations, when we're correlating things, important to understand from a correlation point of view. Here we're looking at, you can correlate between 2 continuous variables. You can correlate between a ordinal and a continuous, and then 2 ordinals. And the important thing with this is there's a scale from -1 to 0 to 1. If something correlates to 0, there is no correlation. If something correlates to a +1, very strong correlation. It's identical, basically, if it's exactly +1. If it correlates to -1, also very strong correlation. Please don't look at the minus and the plus as we do normally in maths. This is just giving you the direction. So the +1 is very strongly correlated, positively correlated. This one is very strongly correlated, but negatively correlated. And when we say positively and negatively, it's just the way the scale looks. This is positively correlated. This is negatively correlated. The slope slopes up with positive, down with negative. So if we're looking at the variables over here, a little bit of variable 1 relates to a little bit of variable 2. A lot of variable 2 relates to a lot of variable 1. In here, it's the exact opposite. Very little of whatever's on scale V1 relates to a lot of V2. And a lot of V1 relates to little on V2. And so important, there is no correlation when it's 0. The closer it goes to +1, the greater the correlation. The closer it gets to -1, also the greater the correlation. And so this just takes you through similar to what I said. Customer X, very little inquiries, low sales, lots of inquiries, high sales. Important to just know the correlation that we're looking at. We look at these two basically, something called the Pearson correlation and the Spearman correlation. This is the most common one that is used, and this is between relationships between ordinal variables. So for the purpose of this course, please understand Pearson looks at continuous variables. It's the most common. Spearman looks at ordinal variables, and that's how you choose which type of correlation to do. The rest of them are important to know that they exist, but it's beyond the scope of this course. Your correlation sizes, here's a guideline. So generally, if we have a correlation of less than 0.2, then it doesn't show a correlation. Now, if we had something between 0.2 and 2.9, generally we'd look at this and say, that doesn't look great. That doesn't look like it's correlated, but from a correlation point of view, yes, it does. There's an attribute of some association between the two, some correlation. 0.3 to 0.49, moderate. 0.5 to 0.8, there's a large correlation, and anything bigger than 0.8 is massive. So important for you to understand this, because we need to understand this for interpretation purposes. So when you see a correlation, you can interpret it. Anything below that, no correlation. But this is where students make the biggest mistake, is they sometimes say no correlation with this, when in fact there is some evidence of association when it's between 0.2 and 0.29. If you're looking at the research and how it comes out, this is the way it would come out. Again, a lot of students look at these ones and think, wow, those are beautifully correlated. The truth is, yes, it is, because commitment is definitely 100% correlated with number one, which is commitment. Satisfaction is 100% correlated with itself. This over here is to be ignored, because this is just correlating things to themselves. So we're not looking at these, we're looking at the rest of these. And if we have to have a look at this particular table and say, where's the biggest correlation? You'll look for the numbers over here for the biggest correlation, and you will see that it's 0.72. That's your biggest correlation. Which is your second, before we get there? So number 4 and 6 are the biggest correlations. So whatever this is looking at, your costs are strongly correlated to a whole lot of alternatives. Which is your second biggest one? And students would normally go here and look here for 0.59, 0.7. They would normally go with this. The truth is, it's not this, it is this one. Remember, this is the second biggest. The fact that it's got a minus next to it is just giving you the slope of the correlation. This is negatively correlated as opposed to positively correlated. So that would be your second biggest one. Please don't get sidelines with the minus. So the alternative is correlated to number 3, which is rewards. So cost and rewards would be quite closely correlated to the alternatives in this particular case. When you're looking, when you're using statistical packages, you would get it like this. So again, there you have your ones, which we can ignore because it's just correlating sales with sales, trust with trust, etc. This over here would give you your mean. This over here gives you the standard deviation, just giving you some extra information. So if you had to use a statistical package, you would get this extra information. And then here are your correlations. And if we're looking to see which is the highest correlated, I would think it's 0.76 over here, if I'm not mistaken. So your sales is very closely correlated in this case to trust. So chances are that if there's great trust, you'll have more sales. That's what that is telling you. And if we look here, the premium is, whoops, sorry about that. The premium is very low correlation between premium and satisfaction. And you can see there's a couple of stars next to these. Now, what this is that the statistical package is actually interpreting this for you. And what they're saying is they're going to put the stars to highlight to you that there is some form of correlation. And you can see here's a 0.24. It's got 3 stars. And this is just telling you there is some statistical analysis between this. The fact that it's a minus, not that important. It's just giving you the slope of it. So hopefully that was useful for you as a summary of the videos that you've already been through.